Okay.
Right. So let me know when you're ready.
Mhm.
Okay. So this problem here, first thing to do is to take the square root of the top and the square root of the bottom. Okay. Now
Mhm.
the bottom's where there's kind of an issue. And for just for times, because you probably won't see this in a while, we'll just run through it. So I'm going to multiply the top and bottom by the square root of y, and you'll see y in a moment. I'm laughing because of course it's the letter y. See why? The top is the square root of a times y. The bottom is the square root of y to the power of 4, and the reason it's the power of 4 is because 3 plus 1 equals 4. You
4.
add the exponents. Maybe you remember that from a earlier lesson we
Mhm.
did. Now the bottom here, whenever you have a square root, it's like to the 1/2 power. So this bottom is really y to the 4th, the 1/2 power, and you end up multiplying the exponents. So 1 is
Mhm.
4, 1 times 2 is 2, 4 over 2 is 2. So the bottom really is, the bottom is really y squared. So your net result is square root of a times y over y squared.
Mhm. Okay. All right.
So we'd love to do another one like that. Actually, we kind of will. We're gonna do 16 next.
Okay.
The reason is that it's most similar to this. So kind of alluded to this. When it's the square root of x, there's really a 1 there and a 2 there. The index is 2. The radicand has a power 1 in there, and this becomes x to the 1/2 power, like that. X to the
Mhm.
1/2 power. Now, you similarly have a 1 in here and a 1 in here. So this first one, x to the 1/3 power. All right. Can you tell me what the second one becomes? It's very similar.
Would be so 1 to the 6th.
Yes, 1/6. Good.
6.
Okay. Now, when the bases are the same, you add the exponent. So we've got to add 1/3 plus 1/6. So we got to make a common denominator. The common denominator will be 12.
Okay. 12.
So the question to you, Josh, what do you multiply 3 by to get to 12?
Mm, 4.
4. So we're gonna multiply the top number by 4. 1 times 4 is 4. What do you multiply 6 by to get to 12?
2.
2. So you multiply the top number by 2.
Plus
This
2.
ends up
Okay.
being 6 over 12, which is 1/2.
Mhm.
So this x to the 1/3 times x to the 1/6 on the left here, it becomes x to the 1/2 power.
Okay. And then this.
And then what we could do is we could say, well, let's write it as a root, square root of x. Why not?
Okay. Root. And then
And that is it. I mean, that is the final answer there.
okay.
All right, so we'll jump back to 14.
All right.
When you get all that down. I don't mean to rush you.
It's okay.
All right, so 14. All right, so what this power of 2 means is that you're really taking what's inside parentheses and multiplying it by itself.
Mhm.
By itself. All right. So this is now a FOIL problem. Do you remember FOIL from previous lessons or from your notes in
Mhm.
class?
Mhm.
Okay. What does F stand for?
First.
First, you're multiplying the first. 6 times 6 is 36. Then you're multiplying the outside. So that's 6 and negative square root of 5. That becomes minus 6 square root of 5. Then the subtraction goes with the root.
Okay.
The inner is minus square root of 5 times 6. You always put the number before the root, just as a preference. You don't multiply inside the root. You cannot do that unless they're both under the root, which is the case here. L stands for last. Minus square root of 5 times minus square root of 5 is plus square root of 25, like that.
Mhm.
Okay. Now, square root of 25 is really 5.
Yeah, 5.
Right? And then from here, you can combine like terms. So there, the numbers without the roots, you got a 36 and a 5, that's 41. You have minus 6 square root of 5 minus 6 square root of 5. So the answer is a square root of 5. And you look at, okay, what's minus 6 minus 6? Well, that's minus 12. They combine together in that way.
Okay.
All right. Any questions on the FOIL? Because I am going to ask you to FOIL the next one. Any questions on how it got these numbers? Anything here?
No.
Okay.
Yeah,
Because what I'm going to do is I'm just going to go back up to this problem. If you say I don't know how to do it, because I can
okay.
answer questions now. Tell me if there's, it's okay if there's not, just asking.
Uh, I think I'm okay for
All right,
foil.
here we go. The next problem, in the instructions, it says to simplify. What that means in this problem is to multiply the bottom by what's called the conjugate.
Okay.
Conjugate is 6 minus the square root of 2. And then you're also multiplying the top by 6 minus the square root of 2. So what I'd like you to do is FOIL the bottom. FOIL the bottom. You can tell them to me. You can wait till you're done. Whatever you want, but I want you to try foiling the bottom, please.
Yes. 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 Inner. Two. No, that's outer. Yeah. Inner. Let's call it and number 6 and 2. And last. Okay, I think I have it correct. I think.
So let me write out the correct answer here. So just on the bottom here, it's 36 minus 6 square root of 2 plus 6 square root of 2 minus the square root of 4. That was
Okay.
not exactly the same as the last one, but hopefully you're in the ballpark. How's that
Yeah,
looking?
it's similar, pretty similar.
Okay, good. Good. So square root of 4 is 2. Okay. 6 square root of 2 negative, 6 square root of 2 a positive. They cancel.
Mhm.
So it's 36 minus 2 on the bottom is 34. Okay, so here's where we live. And we've got 2 on the top times 6 minus the square root of 2 over 34, like that.
Okay.
Is that okay? Clear so far?
Mhm.
All right. On the top, we're going to multiply in. So 2 times 6, 2 times minus square root of 2. So this becomes 12 minus 2 square root of 2 over 34. And then you divide each of these by 34. It's not a choice. You have to do it to both. These both reduce, you could divide both of them by 2, so it's 6/17. Same thing over here, divide them both by 2. There is your final answer.
Okay. Wow. So yeah, we divide those. Okay. But that was 2. That was, yeah. Okay.
Good.
Making sure I have everything correct. All right. We got more flashcards. And then we will go to, uh-oh. Here it is, okay. All right.
Let's take a look here. So we're on to the next page here. We're back to solving. I think these are a little more intuitive because solving, it's like, okay, I'm going to get a number at the end. I'm excited about that. So when you see a problem like this with square roots on both sides, square root equals a square root, the solution requires you to square both sides.
Mm-hmm.
Okay. So when we square both sides, the square undoes the square root. So this becomes on the left 2x plus 11 equals x plus 6.
Okay.
The square undoes the square root.
Hmm.
We've done that a bunch. Hopefully that is coming back. Now, the equation in front of you is something you would have seen in Algebra 1 earlier this year. No, I'm sorry, earlier this year in Algebra 1. Do you remember how to solve something like this?
Maybe I think I do.
Okay,
I
what would
would
be your first step?
to subtract 2 from both sides.
2 is multiplying x. You can't subtract that.
Okay. Because I would assume we would have to get rid of 2 from x.
You do, but it's multiplying it, so you undo it with division.
Okay, so divide 2
So you don't want to do that
by,
first. While that does work, because if you divide everything by 2, which is what you just said, it gets rid of the 2 in front of the x, but makes a fraction, puts a 2 in front of this x and a whole number.
okay.
So probably that's not the right path here. Like maybe it works, but probably not the right path. I'm going to help here. We want to subtract x from both sides.
Okay.
What does the left side become?
It would be just 2.
Nope. You have 2 x's. Think of it as like 2 pencils, and you're taking away 1 pencil.
So you're left with 1.
1x, 1 pencil. Okay.
Okay.
How about from here?
Let's see. So maybe subtract either 11 or 6.
Okay. Well, which one? And remember, your focus should be on the side with the variable. Like you're trying to isolate the variable. We don't,
Okay.
isolation is not usually a positive thing, but in this case, isolating the variable is what the goal is. You want to have just the variable on one side of the equation, x only.
Okay.
Does that help to answer the question?
Yeah, you want to keep the x. You
Okay,
don't want to.
so what's on this side that needs to be
11.
removed? 11. So how do you undo plus 11?
Subtract by 11.
Yes, subtract 11 from both sides. X equals,
That'd be -5.
yes.
Okay. That was
All right.
17.
Any questions on that?
No.
Great. All right, so this problem should have come before the previous one. This one's a little bit easier. You want to first isolate the square root of x minus 7. Okay, so
Mhm.
to do that, you have to undo this subtraction by 3. How do you undo subtraction by 3?
You add it. You add three.
Add 3 to both sides. Okay, now, how do you undo square root?
Oh, what's it? That's good. Uh, I don't remember how to get rid of a square root.
Take a look at what we did in the last problem.
Oh,
You'll
we
see it.
put them in parentheses with
Is that all? Is that all?
we have squared parentheses and squared.
Yes, yes, you have to square both sides of the equation. A square undoes a square root.
Okay.
So x minus 7 equals 9. We can solve that for x, please.
Okay. What would I do? Okay, I would assume subtract 7. I keep it in 9. Okay. Which would be x equals 2.
Okay, that would be true if we were solving x plus 7 equals 9.
Oh, we're doing,
But that's not what we're solving.
then that would be plus on both sides. 17. Okay,
Try again.
16.
16. Yep. No problems if you want to grab a calculator. Yeah, this is
Okay, x equals 16. Okay.
right. Great. Okay, let's do 19. Let me know when you're caught up here. We'll keep moving through this.
Start. Oh, first one. 19. And then okay.
All right, so the first thing here is to subtract 48 from both sides. Just go with it for the moment. This is different than the previous problems, so it's not the same strategy. It's like making cake versus making cookies. It's kind of the same, but different
Yeah.
process. All right, so we're looking for two numbers, and they have to multiply to minus 48, but then they have to add to minus 2.
Oh, okay.
All right, and please use a calculator. Just start dividing 48 by numbers to figure out what multiplies to 48 and gets you to 2, or negative 48 and gets you to negative 2.
Okay. So we're going to
I'm gonna just step away for 30 seconds, but I'll be right back.
Mhm.
All right, I am back. You haven't answered, you need some help. What would
And then something that would equal to negative 2, 8, 9. Okay.
so what I'm suggesting is you take your calculator and you take 48 and divide it by 2. What is 48 divided by 2?
48 divided by 2, 24.
24. Now is like, and you got to think about the signs, but don't worry about that so much for the moment. And I'll just pick this one be negative. Do these add to negative 2?
I would say no.
They're too far apart. They add like 22, and that's way too far apart. So now take 48 and divide it by 3. What does that become?
That becomes 3 and 16.
3 and 16. What do those add up to?
That would be uh 13.
13. Now, if I switch the signs, like let's say I did 3 and -16, it just adds to -13. It's still too big, right?
Yeah,
Then do 48 divided by 4.
that would be 4 and 12.
Okay. Those add up to -2.
No,
Okay, so now try 48 divided by 5.
40 divided by 5. 9.6.
So they've got to be whole numbers, so that does not work.
Does that count?
Okay,
And
so keep going.
then 6 and 8.
Okay, one's positive, one's negative. Does that work?
Yes.
Okay, what is it? Which one's positive, which one's negative?
I would say 6 and -8.
X plus 6, X minus 8 equals 0. Good. Now, important thing here, we actually answered this earlier in the test quiz thing, review. It's, you have to set each of these equal to 0.
Mm-hmm. That one, the pen.
Set them both equal to 0. Go ahead and solve those for us, please.
Okay. Let me just get this written down. X plus 6 equals 0, and then x minus 8 equals 0. Okay. I'm not really understanding how I solve these two.
What did you do here to solve this?
Oh, we did addition, we plus 7 by both sides. Yeah.
Yes.
So I would say let's subtract by 6. That would be x 0 and x minus 2 plus 0. Huh. I did it wrong.
Well, let's not do it wrong, Josh. Come on. Like you just did one here.
Yeah.
In fact, you did the other one over here. If you undo subtraction with addition, you undo addition with subtraction.
Hmm.
Okay. This is not beyond your abilities. You got to push yourself right now to do this.
So I subtracted 6 from both sides.
Okay.
I
So what
got
is the answer?
x equals 0, then x minus 2 equals 0.
Okay. I mean, are you seeing my screen? There's no
Mhm.
way 0 minus 6 is 0.
Oh, okay. That's what I did wrong.
And then secondly, these are separate equations. While you use the same method, it's a different number here.
Oh, okay. Just this, and this. Okay. So let's say we. Oh, hold up. It's okay. Stay there. Uh, Subtract this by 8, both sides. Okay, stay there. That. Minus. So that would be so -6. So x equals -6, and x equals -8.
How do you undo subtraction by 8?
Hmm. Oh, addition, so it's plus. Okay, stay there. Stay there. It's okay. So then that would be 0, and then that would be 8. Okay, so x equals -6, and then x equals 8. There we go.
Yeah.
There's 6, x equals 8. All right.
All right, so
Oof.
21, right? We're gonna skip 20, come back to 20 in a moment, but 21.
Mhm.
This is just like the last. You're looking for two numbers again that multiply to minus 42, but add to minus 19. So you take that 42 and you do just like we did before. You divide it by 2, by 3, by 4, by whatever numbers until you get two numbers that add to minus 19. They've got to be whole numbers. So give that a try, please. I'm going to
Okay.
step away for another 30 seconds, grab my coffee, and I'll be right back.
Okay. Pass this. Okay.
Okay, how you doing on this one?
I think so. Yeah.
Okay, tell me
Right.
what you've done so far.
Okay, so I found -2 and 21.
Yes, very good. So it's x. It ends up being minus 21 x plus 2.
21.
The
And
only
then
way to get
X.
to negative 19 is for the larger one to be negative. So good, very good. Now you set each of these equal to 0. Okay, now we are not going to proceed from this point in the lesson until you give me the correct answers. So please look back to previous problems. Please focus and give me the two answers for x.
Here was subtracted and add. Okay. Was 21. Okay, let's see. So x equals 21, then x equals -2.
Good.
All right.
All right, take a deep breath. We got a couple more problems here. Doing great. I appreciate the effort.
Number 20.
Going back to 20. This is another quadratic, but it's different than the previous ones. Rather than talk about why, we're just going to do here. We're going to add 40 to both sides to undo negative 40. We're going to add here to get 64. X squared equals 64. All right, this is not
Mhm.
the answer, but this is leading us to the correct answer.
Okay.
Now, to undo a square root, if you remember from earlier, we used a square. And it goes
Under
both
the
directions. So to undo a square, you use a square root. But when you take a square root, you have to add a plus or minus to the numerical side.
Here, I'll just write this down. Where root use a square root. Okay.
All right, what is the square root of 64? You are welcome to use the calculator if you would like.
Root of 64. Let me just grab the calculator. Where it was calculator. Um, here we go. Here it is. Square root 64. 8. So that'll be 8. Square root of 64. 8.
Good. So
X
this is
equals
plus or minus 8.
plus or minus. So I have to choose between.
No. Good
Oh,
question. I like the way you're thinking. No, no, no. They're both true. They are both
okay.
true.
Okay, good. Oof.
That would be good for math students. Can I just choose the it's like no.
Yeah. Which one do I choose?
Yeah, all right. Um yeah, it's not yeah, that is gonna go a different direction that. All right, 22 here. So this one is a little bit different than the others. Have we done any what's called completing the square?
Um, Thinking about it, maybe we have.
Well, I don't want to
Um,
do it if you guys haven't, but
hmm. Yeah. I probably have, but just don't understand it. But I don't
I want
want
to
to
be
say
careful
that I have.
here. I want to be careful here.
I don't want to say 100% did
Yeah,
it
okay, so
or
let's not do it that way. So I'm gonna first subtract 1 from both sides. And we're gonna use the quadratic formula on this. I know you've done that. So to do that, you have to identify what's called A, B, and C.
Mhm.
A is 1, B is 2, and C is -1. These are the coefficients.
Oh yeah.
All right, so the quadratic formula says it's -2 plus or minus the square root 2 squared minus 4 times 1 times -1 over 2 times 1.
For one over 2 and 1. Okay.
All
I
right.
do remember doing a little ABC.
Yeah.
Remember
And
something. Yeah.
so we're gonna focus on the part under the root here. 2 squared is 4.
Mhm.
4 times 1 times -1 is -4, but it's paired with this negative to make a positive. So it becomes 4 plus 4. So it ends up being the square root of 8, -2 here with a 2 there.
Mhm.
Okay, we're not done, but that's the kind of the start of this.
Oh, you're smart. Oof.
There's a bit more to do here. So we got to come off to the side here and reduce the square root of 8. Square root of 8 is 2 and 4, 2 and 2.
There are the twos. Two pair. Oh, right there.
Yes.
Okay. I thought something was
Just
with my computer.
nope. Just pausing here, taking a breath. Patience, right? One of the fruits of the
Hmm.
spirit, but I want it right now. That's a joke. You haven't heard that one? Come on, Josh.
Yeah, I know.
Right?
Fruits of the spirit. Love,
Well,
joy, peace.
they're real. They're a real thing, right?
They're real. They're
We
real.
want
I do believe in them.
patience, love. So you got to say you got to say patience, right? You got to
Yeah.
really like emphasize that we need patience because we don't have it.
I try to be patient and have all the
We wa-
fruits, but
we want
they're
our
sometimes
prayers
tough.
answered right now, and a lot of times God says to wait.
Wait.
I mean, just think,
Exactly.
just think how long the Jews waited, not just for, not just in the wilderness, like between um, if you read the Old Testament, I mean, and
Yeah.
historically speaking, I mean, they would go generations without hearing from God,
Oh yeah.
and we're just like, we just want things now. Like, we
Yeah.
need a little more patience.
Exactly.
All right. So
Sometimes
here
it's
we
better
go.
to wait.
Yeah. Yeah. All right. So we're dividing both of these by 2. -1 plus or minus the square root of 2 is your final answer.
Uh, -1 minus 2. Okay. Wow. Okay.
All right.
Math
All
is
right. One more.
definitely
One
math is
more. One.
definitely the patient type.
Yes. Yes.
Breathe out.
Yes.
Wow.
All right. The width of the Bergstrom's dining room table is 3 feet shorter than the length. So here's the length, and then here's the width. And the width is 3 feet shorter than the length. So let's say the length is 7. The width is 7 minus 3, which is 4.
Hmm.
Okay, but we're not going to do it that way. It's not a guess and check problem. The area is 28. So the area is length times width. Okay, so in your
Right.
problem, the area is 28. The length is X and the width is X minus 3. Is that okay?
Uh-huh. Mhm.
All right. Now, to solve this, we have to take the X and distribute it to both terms here. X squared minus 3x. Now, I don't like when the number's on the left, so I'm going to move it to the right. That's totally allowed. But then I'm going to subtract it, which may seem counter to what I just did, but I want everything on one side of the equation.
Hmm.
Oh, so let me know when you get caught up to here.
Okay.
All right, so now this is where you're on up here. We want to find two numbers that multiply to minus 28, but add to minus 3. So take
Okay.
that 28 and you start dividing it. Divide it by 1, by 2, by 3, by 4, until you find two numbers that work.
Mhm. Okay. Think have it. So think -4 and 7.
Okay, those do not add up to -3 though. What do they add up to?
Hmm. They both have 28.
Well, it
So
for sure multiplies to -28, but what is -4 plus 7?
-4 plus 7. That would be like if you owed $4 to yeah. Let's see. Plus 7. Am I sure that's right? It gives me 3.
Right, and you want -3, so that means you have to switch the
Ah,
signs.
okay. So let's do -7 plus 4, -3. There we go.
This is x plus 4, x minus 7. So now you're going to set each of these equal to 0. But they're separate problems. You don't solve them the same numbers. You do the same thing, but you use different numbers or different operations.
Mhm. Okay. All right. So we have to do thing we did in what flashcard was it? It was 21 and 19. Okay. All right. We have to do the same thing. Okay, so x equals -4, x equals 7.
Right. Now, think about the physical problem here. We're talking about a table. The table cannot have a negative dimension. So this one on the left is out. You just cross it out. But
Okay.
this one on the right, this one on the right is good. Okay. So
Mhm.
that is the length. The length is 7. And the width is 7 minus 3, which is 4. And let's put some units with it. 7 feet and 4 feet. So fairly large table.
Yeah.
And that is the final answer. That is what they are looking for for this problem.
Now that I think about it, doesn't seem too hard. Now that I think about it, I guess I'm just too lazy.
Well, I wouldn't say that. I would say you've got a chance here to finish up the course. So there should be some motivation for that. And hopefully get going here. All right. Well,
No
that's going to
pressure.
do it for us for today. I'm going to go ahead and stop right here.